That's why. That's why. It's because I had my microphone muted. Can you hear me now? Hopefully you can hear me now. I don't think that I am. Yay! I was muted. That was my bad. Let's see. I also have the background music muted, but now it's not muted. So hopefully you can hear it. Let me know if it needs to be any louder or quieter. I'm also using my laptop speaker or microphone, so you're gonna get some pretty intense keyboard ASMR. Maybe I should set it up like that for every stream. I kind of like the keyboard sounds. Yay! Yeah, let me know if you can hear me and also the background music okay. I feel like there might be a lot of lag this stream because I don't think my internet is like that great. Not hearing background music, but who needs that when there's keyboard sounds? That's very true, but this is some pretty cute background music, so I just turned it up. Let me know if that is coming through a little bit better. Hopefully you are able to hear it without it drowning out the beautiful sounds of my MacBook Air. Yay! Okay! Thank you so much, everyone, for helping me set up my stream. As always, one of these days, I'm gonna be returning on the same stream setup that I used the week before. Oh no, ads! I turned on ad block. I turned on ad block for a reason. Okay, let me switch to Chrome, because I know my ad block is working on Chrome. I was hoping to keep Chrome off, just because I know it is a little bit of a resource hog. I thought by closing Chrome I was being very clever, but unfortunately I don't have the same ad block situation set up on Safari, so I will just go ahead and open Chrome for our background music. Next week, though, I'm gonna be back at home, not traveling for Anime Expo. I'll be back at home, and I even have like a kind of fancy microphone that I'm gonna set up at my desk, so stay tuned, it's gonna be even better. But yes, while Chrome is slowly opening with all of these tabs open, I would like to welcome everyone home to the stream. Thank you so much for coming back to stream number 2. I'm really excited to be back here streaming more LeetCode. I think we're gonna be getting started on the Explore track this evening. So we'll be learning about probably arrays today. We'll do Arrays 101. It will be lots of fun. But before I do that, I want to welcome everyone home to Midori's computer lab. おかえりなさいませ、ご主人様. Welcome, welcome, welcome. Fun with arrays. Yes, that's what it's gonna be all. Do background music so that I can have array time. Okay, it's opening. Wow, so many windows. All right, I am probably going to open up just one window for YouTube and keep all of my other in VRide Studio, extremely and blue, just like Windows XP. Is anyone else only getting Midori in 160p? Yeah. I was a little worried about that. I don't think that my stream quality is gonna be super good tonight. Hopefully it gets a little bit better than 160 though. Oh my gosh. Yeah, I'm traveling. I'm in LA this weekend for Anime Expo. And unfortunately, I could not bring my fiber internet with me. So we are hoofing it out here in SoCal. Oh, good. YouTube started up. Okay, let me pull up Tsundere Twin Tails. They have very cute background music that hopefully will not get my stream taken down. Actually, the YouTube video is buffering. The struggle stream this week, but we're gonna get through it. We're gonna get through it, and we're gonna have, most importantly, some fun with arrays. Last week we finished the beginner challenge problems. That was a lot of fun. We saw some very creative solutions to some of these problems. And this week we are moving on to the second part of the Welcome to LeetCode starter pack. Common question when joining LeetCode is where should I start? Because yes, there are hundreds of thousands, I think. There's a lot. There's a lot of LeetCode problems. We are not just gonna go through them in order today. Maybe another time. But instead, they have this little guide, where should we get started. They have a couple of different tracks, depending on what you are trying to achieve. Oh, welcome, Dev God Sama. おかえりなさいませ、ご主人様. Welcome to the XP Vibes stream. No, the stream dropped. At least you're getting it in 720p. Yes, as I have been explaining, I am traveling for Anime Expo this week, and so we are on the struggle bus in terms of internet connectivity. So I apologize, you may be seeing me at 10 frames per second, 160p. Not my usual, but as Siki-sama has pointed out, it is the true real player vibes for the XP aesthetic, so you can relax in the stream and imagine that it is the year 2005. going to your first anime convention and watching YouTube poops with your friends. um, so we are going through the LeetCode where to start. So they actually say uh they have like all of these different things. So they're like, oh, if you're looking for to learn about data structures and algorithms for interviews, they've got a crash course for that. They've got a fast track if you don't even have time for this questionnaire because your interview is in a few weeks. They've got all of these different tracks, and then they do mention that if you are new to programming, you're learning your first programming language, you have a lot of the syntax down, but you're not super confident yet. They say we recommend that you start at the beginner track. But if you go to the beginner track, it actually is just a page saying there is no beginner track. Oh, put up with the calming sound of my keyboard instead, because this this YouTube video is not cooperating with me, so unfortunately I did not download soundtrack ahead of time, so that's just how it's gonna be. How many LeetCode's problems have you done? Not very many. So I actually am a programmer in my day-to-day non-VTuber life. So I've done a fair amount of programming, but I only did, a couple of LeetCodes back in college when I was, interviewing for my first jobs. I did like a handful, and I did just the beginning, like first couple of challenge problems last week. But yeah, I haven't done a ton of LeetCode. The reason that I decided to start streaming these is just because I thought it would be fun, a fun little game to stream. I definitely miss problem solving with my friends when I was a student, and I thought that these could be a chill way to hang out with some cool folks and solve these problems together. So yeah, so what's funny is that they say if you're new to programming, they recommend the beginner track. But if you click on beginner track, it just says we don't offer any beginner track. And there's not really a ton of resources on this page, so lucky for all of you if you are new to programming, I am here to teach you. You've come to the right computer lab. So they really should just put my face on the beginner track and say, go learn from an anime maid on Twitch. But for the kind of next step up, they have the Explore card track, and that is where I think I'm gonna start with all of you, all of my viewers, because this is kind of a guided tour of different algorithms, different data structures, and different approaches that you will often use to solve the problems that come up in LeetCode. So I thought that would be an excellent place to start with all of you. And they even have kind of like a recommended order to go through these cards. And so the very first one that we're going to be starting with today is Arrays 101. So again for today, because we already are going to have so many technical difficulties just from my traveling and being away from my PC at the moment, I am gonna keep it simple and keep on programming in TypeScript. But if you come join me next week when I will have a much better microphone and a much stronger internet connection, I may also put up a poll to see what language you might want to see me try to code in. I do have the most experience in JavaScript and TypeScript, but I have also done a fair amount of Elixir, which I found very fun. I used that for a couple of personal projects back in the day when Elixir was kind of the hot commodity in the programming world where I was at the time. I also have a little bit of Ruby experience and am interested in picking up more languages, Python, Haskell, whatever you guys want to see. I'm happy to use this as a learning opportunity as well. Maid Sensei, what is your favorite data structure? Well, it's kind of a boring answer, but I have to say hash maps, mainly because I am a TypeScript enthusiast by trade, and almost everything in JavaScript, TypeScript world is a JSON object, which I believe is like the JavaScript version of hash maps. I'm gonna feel real silly if it turns out that hash maps are actually a completely different thing. But yeah, I use JSON so much every day, so that is probably my current favorite. But like I said, I am not new to programming, but very new to LeetCode style, algorithm, optimization, riddle type problems. So I'm sure that through doing these explore cards, I might find some new favorites. Yeah, but I'm curious for all the viewers in the chat, what kinds of well, what's your favorite programming language that you like to code in the most? And also, I'm also curious what your favorite data structure is. I would love to hear your favorites and also why. Elixir is pretty cool because it's very functional programming. I was learning Elixir and also Cypress, I think is what it was. No, Elm. Cypress is testing framework, I think, but I was also learning Elm for like front end. And Elm, I should do some Elm streams at some point because I always felt like every hour that I spent trying to do the most basic thing in Elm, I felt like it was making me like so much smarter. But it was like Elixir wasn't too bad for me to pick up compared to kind of like the functional-ish JavaScript that I had been doing, but Elm just felt like a completely alien language compared to what I was used to. My point of view is that JSON is both hash maps and lists. Yeah, that's fair, especially because JSON, like, just an array is a totally valid JSON object, so that makes sense. JavaScript is also your favorite as well, since it's an everything easy language, websites, Node.js, server-side stuff, npm package for everything you could want quickly. I agree, especially with like TypeScript in the mix. I feel like everything comes together so naturally. Don't put Python in the poll unless you want me to vote for it. Well, I'm not opposed to learning some Python. I think I am long overdue to learn some basic Python for sure. Tied with Java for your favorite is JavaScript and Python. Yeah, nice, easy languages for sure. Okay, so starting with the introduction, arrays are a simple data structure for storing lots of similar items. They exist in all programming languages and are used as the basis for most other data structures. On their own, arrays can be used to solve many interesting problems. Arrays come up very often in interview problems, and being a guru with them is a must. In this Explore card, we'll introduce arrays and solve some cool problems with them. This card is beginner friendly, and we've provided lots of code snippets in Java to help you understand. Each topic begins with informative articles, followed by real interview problems for you to practice on. In addition, the problems have hints, which will help you in building up ideas on how to solve them. These hints will be subtle enough to set you on a particular path for reaching the optimized solution without giving away the answer too easily. After completing this Explore card on arrays, you will understand what an array is, basic properties of arrays, implementing basic array operations, simple programming techniques with arrays. Before you start, bear in mind that should you have any questions or comments, you can always post them in the discussion forum that is located at the end of the card. We'll do our best to respond to you as soon as we can. Okay, great. So we've got, oh, this is actually kind of long. Okay, I thought maybe we'd do the whole card tonight, but especially given that the internet situation is a little rough tonight, I'm probably just gonna do a quick stream at this point, so we might get through the first, 1 or 2 sections and leave the rest for next week. But let's dive in. A DVD box. Wow. Okay, there's definitely people doing LeetCode now that have probably never held a DVD box in their hands, which is a little bit scary. But let's say you have a bunch of DVDs at home that you wanted to arrange neatly. That is, that's always me. I can relate to that. What would be the ideal choice for storing such a thing? You could find a cardboard box or some other box big enough to arrange all of the DVDs neatly, right? It's as simple as that. However, you might want to add a new DVD to the box, or you might want to get rid of the old ones that you've watched a million times over in the past. An important consideration for this box would be that you would only place DVDs in it and nothing else. You wouldn't place your clothes in it, for example. The box would contain multiple items, but all of them would be of the same type. In this case, that type is DVD. Items of the same type share properties. For DVDs, these properties include all the DVDs would be inside a plastic cover. The cover would have the name of the movie, the cast, and all sorts of other details. All the covers would be of exactly the same size and would contain just one and only one DVD. You might not actually name the DVD box, but when you want your sister to fetch a DVD, you tell her that the DVD is inside your quote-unquote DVD box, and she would instantly know where to find the box. This is a very simple yet realistic scenario that is easy to understand and relate to. So now let us move over to the world of computers and port this example to programming. Suppose you were told that you needed to build some software to keep track of all the DVDs in an inventory. This is the exact same scenario that we just described above, but on a much larger scale. So let's imagine the DVD box as a virtual DVD library. For each DVD, you would have certain properties that would be specific attributes of the movie themselves. In addition to the properties of a DVD, you're also told the maximum number of DVDs that can be stored in the inventory. Obviously, you wouldn't want to store ancient movies from the 1900s unless they were popular ones, right? Okay, when you say 1900s, do you mean like 1999 though? Say you were told that the requirement is to maintain a maximum inventory of just 100 DVDs. This is an important piece of information because without this, you wouldn't be able to find the perfectly sized box to fit all the DVDs easily. How could we find a box of a particular size that would be able to fit a maximum of 100 DVDs? Well, lucky for us, we don't need to physically find a cardboard box or anything. There's a programming construct for this purpose, and that program construct is known as an array. But what is an array, I hear you ask? An array is a collection of items. The items could be integers, strings, DVDs, games, books, anything really. The items are stored in neighboring, contiguous memory locations. Because they're stored together, checking through the entire collection of items is straightforward. So how can we relate this back to the physical DVDs? Well, do you keep your DVDs all around the house in multiple locations? Hopefully not. Yeah, totally not. I would never. Most people keep all of their DVDs right next to one another inside one gigantic box or perhaps on a bookshelf. We do this so if we need to find a particular DVD, we can quickly search through all of them without running from room to room. But if you run from room to room, you're getting exercise, so it's actually much healthier for you to keep your DVDs in multiple different locations. That's what I'll tell myself. On a computer, arrays can hold up to n items. The value of n is decided by you, the programmer. at the time that you create the array. This is the same as when we found a big enough cardboard box for the DVDs. Additionally, you also need to specify the type of item that will be going into the array. In Java, we use the following code to create an array to hold up to 15 DVDs. Note that we've also included a simple definition of a DVD for clarity. So we got our DVD collection, which can hold 15 DVDs. Our DVDs have a name, release year, director, a constructor that takes all of those values initially, and we've also got toString, which gives us this nice handy little print line, or line that we could print line. After running the above code, we now have an array called DVD collection with 15 places in it. Each place can hold one DVD. At the start, there are no DVDs in the array. We'll have to actually put them in. The array can only hold up to 15 DVDs. If we get a 16th DVD, we need to make a new array. We'll look at how we deal with running out of space in the next chapter. Before we move on to actually putting some DVDs into the array though, one thing you might be wondering is why we'd make an array with only 15 places. Why not just make it hold... Oh! I hope that didn't really kill your ears, but thank you so much for the follow. Thank you, thank you. Let me know if that was way too loud, by the way. I can definitely turn down the volume for the follower alerts. Thank you so much for the follow, though, Dev. Okay. Why not just make it hold... Oh my gosh, how many zeros is that? 1, 2, 3, 4, 5... Okay, I think it's 1 million? Yes, 1 million. Why not just make it hold 1 million DVDs so that we know for sure we'll always have enough space? Well, the reason is the same as it is for the physical box of DVDs. Do you really want to find a box that could hold 1 million DVDs when you currently only have 15? And in fact, never expect to own more than 100 of them. Is it even worth getting a box that could hold 100 DVDs right now when you only expect to get a few new ones each year? It will take up a lot more space in your home in the meantime. It's exactly the same with the array, where the space in your home is analogous to memory on the computer. If you make an array with 1 million spaces, the computer will reserve memory to hold 1 million DVDs, even if you only put 15 DVDs into it. That memory can't be used for anything else in the meantime, just like space in your house that has been taken over by that huge cardboard box. That actually makes me wonder about JavaScript arrays where they don't make you define the number of spaces. Is it doing something fancy to make it not take up 1 million spaces, or are computers just cheap enough these days that we are building 1 million spot DVD boxes every time? Foreshadowing, exactly. Foreshadowing for dynamic array size in JavaScript. But I guess for most languages, you do have to define the space. If DVDs are old and are stored in arrays, then are Blu-rays that are newer stored in a cooler data structure like hash maps? I guess we'll just have to keep reading to find out the answer to that question. See an array list. Garbage collection, go burr. Memory management, something something, exactly. I'm sure that JS memory leaks are pretty common though. Okay, accessing elements in arrays. The two most primitive array operations are writing elements into them and reading elements from them. All other array operations are built on top of these two primitive operations. Writing items into an array. To put a DVD into the array, we need to decide which of the 15 places we'd like it to go in. Each of the places is defined using a number in the range of 0 up to n-1. The first place is 0, the second place is 1, the third place is 2, all the way up to the 15th place, which is 14. We call these numbers that identify each place indexes. Do you pronounce it indexes or indices? I kind of pronounce that both ways, depending on my mood. Let's put the DVD for the Avengers into the 8th place of the array we created above. So they instantiate a new DVD and then assign that to DVD collections at index 7. And that's it. We put the DVD for the Avengers into our array. Let's put a few more DVDs in. So they create new DVD The Incredibles, new DVD Finding Dory, new DVD The Lion King, and then file them away in index 3, 9, and 2 respectively. Notice that we put The Incredibles into the array at index 3. What happens if we now run this next piece of code? Ooh, we created Star Wars and then put it into the same index. Because we just put Star Wars into the array at index 3, The Incredibles is no longer in the array. It has been overwritten. If we still have the Incredibles DVD variable in scope, then the DVD still exists in the computer's memory. If not, though, it is totally gone. Reading items from an array. We can check that what's at a particular array index. So we can system out println the DVD collection at index 7, 10, and 3, and then it will print the Avengers, null, because we didn't put anything into box at index 10, and then Star Wars in index 3. Notice that because, oh yep, there it is. Because we haven't put anything at index 10, the value it contains is null. In other languages such as C, the array slot could contain completely random data. Java always initializes empty array slots to null if the array contains objects, or to default values if it contains primitive types. For example, the array of integers would contain the default value of 0 for each element. Float would contain default values of 0.0, and Boolean would contain default values of false. Oh, that's interesting to know about Java. I have done a little bit of Java programming, but not in a really, really long time, so I remember next to nothing about this language. Writing items into an array with a loop. We commonly use a loop to put lots of values into an array. To illustrate this, let's go to another example. This time we're going to create an array of integers and put the first 10 square numbers into it. So we have our square numbers integer array, and then we go through while I is less than 10, and we square the number, and then we assign that number to the ith index in our array. How fun! Reading items from an array with a loop. We can use a loop to print out everything that's in the array. So we similarly go through each index and then system out println each and every one of them, printing all of those squares. One last thing worth noting now is that there's a more elegant way of printing out the values of an array, a variant of the for loop commonly referred to as a for each loop. So instead of using the index, we can do for int square, which is a value of square numbers array. We just print out that square. You'll probably agree that this code is a lot simpler to read. We can use it whenever we don't need the index values. For actually writing the squares into the array, it wouldn't have worked because we needed to work with the actual index numbers. You don't have to use a for each loop when you're starting out, but we recommend you become comfortable with it before interviews. Simple, elegant code is good code. I actually think that the code that runs is good code. Let's not get ahead of ourselves with expecting the code to be all of those things. Okay, array capacity versus length. If somebody asks you how long the DVD array is, what would your answer be? There are two different answers you might have given. The number of DVDs the box could hold if it was full, or the number of DVDs currently in the box. Both answers are correct, and both have very different meanings. It's important to understand the difference between them and use them correctly. We will call the first one the capacity of the array, and the second one the length of the array. Array capacity. Let's say we've created a new array like this. Is it a valid operation to insert an element at array index 6? What about at array index 10? Nope, neither of these are valid. When we created the array, we specified that it can hold up to 6 DVDs. This is the array's capacity. Remembering that indexing starts at 0, we can only insert them at array 0, array 1, array 2, array 3, array 4, and array 5. Trying to put an element anywhere else, such as array of -3, array 6, array 100, will cause your code to crash with an array index out of bounds exception. The array's capacity must be decided when the array is created. The capacity cannot be changed later. Going back to our DVDs in a cardboard box analogy, changing the capacity of an array would be akin to trying to make a cardboard box bigger. Trying to make a fixed-size cardboard box bigger is impractical, and it's the same as an array on a computer. So what do we do if we get a 7th DVD and we'd like all of our DVDs in the same array? Well, unfortunately, it's the same as it is with our cardboard box. We'll need to get a larger one and then move all the existing DVDs into it along with the new one. The capacity of an array in Java can be checked by looking at the volume of its length attribute. This is done using the code array.length, where array is the name of the array. Different programming languages have different ways of checking the length of an array. Running this code will give the following output. The array has a capacity of 6. Yep, it's a bit confusing that you need to access the capacity of an array by using .length. Unfortunately, this is just something you'll need to get used to. Array length. The other definition of length is the number of DVDs or other items currently in the array. This is something you'll need to keep track of yourself, and you won't get any errors if you overwrite an existing DVD or if you leave a gap in the array. You might have noticed that we've been using a length variable in our previous examples to keep track of the next empty index. So they create their array of integers. Length is defined as 0, and then they increment the length every time they add an item to an array. Really? Java doesn't have a dot count or anything like that you can use? Returning this code will give the following output. Wow, maybe Java really doesn't have dot count or anything. I guess it kind of makes sense because, if it's initialized with a non-null value, like if you made an array of integers and everything started at 0, I guess that kind of makes sense. Handling array parameters. Most array questions on LeetCode have an array passed in as a parameter, with no length or capacity parameter. What do we mean by this? Well, let's look at an example. Here is the description for the first problem you'll be asked to solve. Given a binary array, find the maximum number of consecutive ones in this array. And here is the code template you're given. Public int, find max consecutive ones, is an array of integers called nums. The only parameter is nums, an array. You couldn't possibly solve this question without knowing how long nums is. Well, luckily it's straightforward. When an array is given as a parameter without any additional information, you can safely assume that length equals capacity. That is, the array is the exact right size to hold all of its data. We can, therefore, use .length. Be careful though, arrays are 0 indexed. The capacity and length of a number of items, the capacity/length is a number of items, not a highest index. The highest index is .length -1. Therefore, to iterate over all items in the array, we can just do the following. For int I equals 0, I less than nums.length, I plus plus. And then we can do something with the element. And that is the basics of arrays that you'll need to get started. In the next chapter, we'll look at some of the fundamental techniques we use to work with arrays. Before that, though, we have a few introductory array problems for you to play around with, starting with the one we looked at briefly above. Enjoy! Python allows negative indexes for lists. Oh, that's interesting. Does it put it like from the back? Like if you do like -2, is it like second from the back or something like that? All right, you're finally gonna get to hear some typing ASMR. Given a binary array nums, return the maximum number of consecutive ones in the array. Oh, interesting. I actually have no idea if JavaScript has something similar to that. I don't think it does, or at least I've never used it. Okay, so we have our input is a list of zeros and ones, an array of zeros and ones, and we're supposed to count up the maximum consecutive ones in the array. Okay, let's do this in TypeScript, since that is what I am most comfortable with these days. All right, so we have our nums. So we can do nums.map. The Linux developer background and content are pure bliss, but Windows makes me hiss. You know what's funny is that, so right now I am actually on a MacBook, and that's because I'm traveling, and normally when I'm at home, I would be streaming off of a Linux PC as well. So, you know, I am living for the nostalgia here, not necessarily the operating system. To be fair, though, back when I was a wee lad, I definitely was a bit of a Windows stan back when I was young and naive. Welcome, Linux developer sama. O kaえりなさいませ, ご主人様. Welcome to the chat. We are doing some basic array LeetCodes right now. Right now we are just counting the maximum number of sequential ones in a binary array. So to do that, I am doing .map of a num. The buffering made you miss my response. Oh no! I'm so sorry. I'm so sorry about that. The TLDR is that I completely agree with you. I would normally be streaming on a Linux PC were I not traveling, and am in fact currently on a MacBook. I haven't used Windows in quite a very long time, but I still live for the nostalgia for sure. I think that this is going to be a little bit simpler if I just use a for loop. So for int for var I guess let I equals 0, I less than nums.length, I++. We probably want to go until, well, let's see. We might need to go nums.length -1 or something, but let's see. So we would do nums at I. Basically, we want to create like a counter like let consecutive equals 1, and then if nums at I is 1, oh wait, we want to start with 0, don't we? If nums at I is 1, then we are going to consecutive plus plus, else we want to keep track of all of them, don't we? So we probably want to consecutive ones. We'll start it as an array. And if nums at I is 1, we're going to check if I guess we'll start with the 0. Consecutive ones.pop is going to be const last count, and then we can consecutive ones.push last count plus 1. And then if we are a 0 instead of a 1, then instead of incrementing the last count, we will instead consecutive ones.push 0. I think this should work, because in the very first one we start at 0, and the first one that we find, we're going to increment that, and then whenever we hit a 0, we are adding a new counter to the end, and then at the end we can say return consecutive ones.sort. I think that should work. I can't remember if .sort is what's the word, like persistent, like does it mutate the consecutive ones, or does it return a new array? I think it mutates, so I'm just gonna try it. So consecutive ones.sort, and then return consecutive ones.pop, maybe longest, return longest. Let's see how that goes. Run code. Compile error, cannot find the name consecutive ones. Did I make a typo? Oh, and Python list.sort mutates and sorted list returns a new list. Oh, that's interesting. Is that like a typical pattern that's used in other things in Python? Yes, I made a typo. Okay, so this is working. I bet that I could turn this into a map, which would make my heart quite a bit happier. Oh, thank you so much for the follow. Thank you so much. Was that the Linux developer? I hope so. It was hard for me to see the pop-up because of the way I have my things configured. Does it show me Does it show me in the activity feed? Yes, thank you for the follow, the Linux developer. Yay, thank you so much. I really appreciate it. Aspigens is more curious if TypeScript has both kinds of sorts. You know, I'm not sure if there is like a functional sort, a non-mutating sort function. That I'm actually not sure about. Let's see, TypeScript non-mutation sort. What does Stack Overflow say? Oh, two sorted. That's pretty exciting. I wonder when two sorted was introduced. That's the compatibility. Where does it say? Browser compatibility. JavaScript two sorted. When was it introduced? Am I gonna resort to the Google AI? Maybe. What does Google AI say? Introduced in 2023. Ooh, that's pretty recent. Yeah, I guess it's a pretty new feature of JavaScript apparently. That's pretty cool. So yeah, let's make this a little more functional, shall we? So instead of keeping track of consecutive ones in this way, we can say const consecutive ones is equal to nums.map. Take a num and do stuff with it, and then the accumulator is going to be an array. Very nice to meet you, the Linux developer. I hope I'll see you around. Enjoy playing Jedi Fallen Order. I don't know, is that a new game or an old game? It's fun. It's fun playing old games on brand new monitors, but it's also fun playing them on retro hardware as well. All right, so in our, oh, not a map, reduce. PS4 era. Oh, that's just getting older. It's still, it's still relevant. Okay, so in our reduce, lambda, if num is equal to 1, then we are going to const last equals accumulator dot pop, and then act dot push last plus 1, return ACK, else ACK.push 0, return ACK. That should do what this was doing. And then const sorted equals consecutive ones dot to sorted, I think is what it was called. Thank you so much. Thank you so much, Linux developer Sama. We will see you again soon. Okay, use the more functional to sorted, and then longest is going to be sorted dot pop, and then we return the longest. Hopefully I did not make any typos. Yay! Okay, seems like it worked. So we can go ahead and submit. Hopefully it will show us how, oh, wrong answer. More details. What did I get wrong? Wow. Wow. Okay. Output 98, expected 375. What happened? Can I, like, debug this? Can I do debugging? Okay, we have our code. And then how do I debug? Upgrade to premium to use the debugger. Okay. How do I get around that? Test case. Test result. Test case. Case 1. Case 2. Okay, let's run it again. Oh yeah, TV Josh, you are absolutely correct. TypeScript doesn't have like methods outside of the JavaScript methods, but we did manage to find that JavaScript actually did add a more functional. Oh, wait. It didn't keep all my code. Did it? What is happening here? Oh no, it did. Okay. We are good. TV Josh, welcome, by the way. Welcome. おかえりなさいませ、ご主人様。Is time stopping? I don't think time is stopping. I'm not quite sure what that question means. But as far as I know, time is marching ever forward. Quite diligently. Okay, so this is the one that failed. I wonder if oh, that is too many. I can't even see the whole test case. Okay, and it's not gonna let me. Okay. Use test case? Yes! Okay, let's close these out. That is so many numbers. Okay, and then I wonder if I can do a console log. Can I do a console log and see it? Unfortunately, I do not have a good developer environment set up on my laptop right now. So otherwise I would just pop this over to VS Code. I wonder what happens if I run this. Standard out. Here we go. Okay, and then what do I get if I look at... That sure looks like an issue with toSorted. Zero, 1, 1, 10. Oh, haha! Yep, this is what I suspected. We need to give it a lambda. So xy, return x minus y. Maybe that will work. It was sorting them alphabetically and not numerically. Yeah, that looks way better. And now it is returning the correct number. Yay! Yippee! Okay, let's submit it again and see if it passes now. Oh, and let me also remove the console log because that may impact performance, I suppose. Oops. Did not mean to delete all of that. Okay, let's submit it again. Okay, our runtime is pretty poor. We do not beat anyone with our runtime, that is for sure. Can I look at memory as well? Yeah, not very good memory stats, not very good runtime stats. That's okay. Show us your code. It's right here. This is the code. So yeah, there's definitely ways that I could improve this a lot. For one thing, instead of keeping the list like this, I could probably make this a lot better. Yeah, I probably don't need to do list manipulation. I think you're right. I can probably just keep track of like the longest so far, and then whenever we would have added something to the array, instead we can just replace the running longest. Let running longest equals 0. Let current count equals 0. And I'm just gonna go back to a good old-fashioned for loop for let I equal 0, I less than nums.length, I plus plus. Oh, we got a paper crane in here. Let me try this and then we'll see how this one goes. Okay, so going through this, if nums at I equals 1, then current count Yeah, I do apologize. I have been traveling this week for Anime Expo, and so I am streaming on a bit of a shaky internet connection, and also not at my usual PC. So I really do apologize that you are probably viewing me on pretty shaky internet right now. XP era maid programmer has XP era internet. Extremely true, sadly accurate. Okay, and then if it's 0, then instead we will check running longest equals math.max of running longest and current count. My dad picked the phone up exactly. Exactly. And then we will also set current count to 0. And then at the end, we will return math.max running longest and current count. All right, let's see how that does. First of all, does that pass? Oh, I think I only have one test running right now. Well, it passed that single test, so let's see how it goes in the long run. Much better. We are on top of the bell curve. So not doing too much better than the average person, but we are doing extremely adequate here. Same thing for memory. We have done extremely adequate. I'll take that. Let's try Siki-sama's idea now. Oh my gosh, my college dorm's terminal room had acoustic modems featuring cases made of actual wood. That is really incredible. We're not that retro in this stream. We're only a little bit retro. Alright, so Siki-sama said we have a function, a and c equal to 0, so the, okay, that's a thing. And that is a function that it returns a.reduce m and x. I'm guessing that m and x are just, I'm gonna call this accumulator and x is value, because if this is a reduce, that's gotta be what it is. Okay, it's gonna do something, and then a.reduce mx. Okay, so 0 is the initial accumulator. And inside this accumulator, if m, the accumulator, is greater than c equal, oh lord, value times minus tilde c. If I'm remembering from last time, this minus tilde C. I thought that what this did was that if C is null, it's just C unless C is null, and then it's 0. I thought. I'll have to look that up later. If that return the accumulator, otherwise return C. Did I translate that? Did I expand that properly? How can I get more test cases back? I cannot. It's gone forever. That's okay, I'll just submit. See what it said. Like that. Okay, let me start by just copying and pasting, and then I will... Oh, a function, right, because I didn't return anything. So... const foo. And then do I return foo of nums? Okay, so what's going on here? We've got A and C. A is nums. And nums array, just to make that nums array. And then C is the longest chain. Okay, what is this doing? Longest chain equals val star minus tilde. Well, okay, so val is either 0 or 1, so that's cute. If it's 0, then longest chain is being set to 0. If it's 1, then it's being set to 1 times minus tilde longest chain. JavaScript tilde. What if the last one is a 1? What sorcery is this? I think this like minus tilde thing is doing the heavy lifting here. Maybe. Let me remind myself what the tilde operator does. Bitwise not. Bitwise not. Okay, the bitwise not operator returns a number or bigint whose binary representation has a 1 in each bit position for which the corresponding bit of the operand is 0 and 0 otherwise. So 5 becomes -3. Oh, thank you so much for the follow. Jarv SP. おかえりなさいませ、ご主人様. Welcome to the stream. Welcome, welcome. We are currently just trying to unpack some JavaScript sorcery and learning about the bitwise not operator in JavaScript. It flips all of the bits in the integer. Console.log. So A was 5. Oh, yes, okay. And the output is -6. B is 3. The output is 2. Ah, okay. I remember what this does. Okay, so the bitwise flip is like the bitwise not of an integer, of a positive integer, is, if it's n, the bitwise flip of n is minus n plus 1, and it is also minus n plus 1 for negative numbers. So the minus of the bitwise flip is just n plus 1. But instead of, I thought it was to handle when something is null. But we wouldn't need to do that here because we're already setting longest chain to default to 0. So longest chain is never going to be null, I think. But what we are doing is we have, okay, so we're going through we're reducing numbers array. The accumulator starts at 0, and then we're checking. So let me expand this a bit more. So longest chain equals val times minus bitwise not longest chain, and then simplify that a little bit, unpack this a little bit more, make sure that still works. But yes, we are setting longest chain to be the value times essentially longest chain plus 1. And I am so curious if we do longest chain plus 1, if that will do the exact same thing in this case, because I thought that the minus of the bitwise flip was to account for undefined. So let's run that and see if that still works. Yeah, that still works, and we can make this look even more legible if we do if well, this is still pretty legible, so I'll leave it like it is. So basically what we're doing is we're setting this longest chain, and this actually is not the longest chain. Let's say current chain, because it's not the longest, it's just the current chain. So current chain starts at 0, and then we are setting current chain to the value times current chain plus 1. So if the value is 1, then we are basically incrementing current chain. If the value is 0, then we're resetting current chain to 0 in this line. And then if the accumulator is greater than the current chain, accumulator starts at 0, but if the accumulator is bigger, then we return the accumulator. Otherwise, if the accumulator is smaller, then we return the current chain, and that becomes the new accumulator. So to answer your question, what if the last one is a 1? In this case, that doesn't matter, because we are always keeping track of the biggest current chain, and we are incrementing before we do anything. So yeah, that is a fun little one-line solution that is impossible to read. I love it. All right, I'm not going to get too caught up on the trying to optimize even more. Instead, I'm going to continue on and check out the next exercise. All right, find numbers with even number of digits. Given an array of numbers of integers, return how many of them contain an even number of digits. So in this case, the output is 2 because we have 12 and 7,896. Both have even number of digits. Okay, there's some hints. Let me start with the hints. Let me start with the very basic example, and then I will go in for the hints. And can I just open this up? Can I just open it? Nope. Okay, that's fine. All right, so we've got our list of numbers. And the very simple way to do this is nums dot reduce once again, the accumulator and the number. I got an extra parenthesis somehow. And then the accumulator starts at 0, and for each num, if num dot split, I think maybe I need to do dot to string dot split dot length mod 2 is 0. Hopefully that works. Then accumulator return accumulator plus plus. Otherwise, return accumulator. And we can just return that. I think that should work. Yay! And submit. Wrong answer. The output was 0, but it should be 2. It's interesting. I wonder why that is. All right. Let me console.log. Before we do that, let me just run it and see if the test case is in there. Yeah, test case is in there. So console.log num.toString. Split dot length %2. Let's see what is happening there. Zero. What do I need to accumulator ++ and then return accumulator? Is that why? Yes, that is why. That is so why. All right, so kind of the easy dumb way is we are going over all of the numbers. We are keeping track of this accumulator, and at every number, we split the string. We count the length of those that string. Actually, we don't even need to dot split. We can just do num.toString.length. That should work. Yeah, that should work. Yeah, because strings have that. Strings have a length property. So we toString the number, then we check the length, and we modulo 2 to see if it's even or odd. If it's even, we plus the accumulator and then return. Otherwise, we just pass on through. Let's submit our answer and see how it does. All right, we are once again right in on the tippy top of the bell curve. Memory-wise, we are bell curve-ish, I would say. Let's see what the hints are. If there's any hints that could make this. How to compute the number of digits of a number, and then divide the number by 10 again and again to get the number of digits. Well, if we do that, is it going to be any more performant? Let's see. Const count digits. Of a number, and then if num over 10 is greater than 1, I guess, while it's not a fraction of a fraction. if num over 10 is greater than 1, then we return count digits of num over 10, else return I guess we need like a counter. I plus 1. What am I trying to do with split? What I was doing was split was basically turning the string into an array. So num.toString turns the number into a string, and then string dot split basically splits each character of the string into an array. So I was doing that to count how many digits, but then I remembered that the string actually does have a length operator that I can just use. So that's what I was doing before I remembered that string has that built in for us. And then we are going to, if we are less than 1, then we are going to return I. And am I going to be off by 1? Let's see. If I put in 9, it should return 1. If I equals 1, that should work. That should work. Okay, so then instead of this, we will do if count digits. Oh, I have a potential second optimization, but let's try this first. If count digits of num modulo 2 is equal to 0. Okay, let's see if that works. If num number expression expected I always forget the syntax here. I think that's right. Const count digits, line 2. Oh, because I forgot a parentheses. All right, let's try that again. Okay, that seems to be working, so let's submit. See if that got us any further up on the, wrong answer. Output was 0, expected 1. 1, 2, 3, 4, 5, 6. Do we need to do like greater than or equal to 1? Oops. Wrong button. Wrong direction. All right. That did worse. That's okay. We've got I as number, and then what would be even more efficient is are digits even? And instead of let's call it ACK. We will, and instead of a number, let's make it a Boolean. It starts off as false. Not ACK. Return ACK. And then if are digits even, all right, hopefully that improves things a little bit. Oh, damn. Is that true? Is that true? Did we really just go from the top of the bell curve to the very, very tippy end? No. It is just not. Runtime is non-deterministic. All right, I am not putting too much stock into the runtime here. As visions with the real answers, did the problem state that using base 10 was required? Using base max int and always return 0 would simplify the problem. Wait, I don't get it. Base max int. Base max int, like the biggest possible integer value. I forget what happens when you convert from one base to another. Like, convert 1 to base 100. From base to base 36, what happens? Oh, because, I think I understand. Because if max int is the base that we're in, then every number is a single digit number. Is that, is that how that works? I think I understand. Yes. Because max int is the biggest possible number for an integer to be defined as, and anything less than that is considered a single digit number in base max int. And so because of that, every single value in the list would be considered a single digit base max int, and therefore the answer would always be 0 because every single value would have an odd number of digits, aka 1 digit. I like that. I like that. That is a good solution. I think that really adheres to my no code ideology of programming. You escaped the Inquisitors for now. It seemed like a good stopping point. Oh, congratulations on escaping the Inquisition. LeetCode is going pretty good. I continue to be reminded that their little like runtime thing is completely non-deterministic and doesn't actually mean anything. So someday when I have a couple more brain cells firing in my noggin, I should probably remind myself how to do like runtime and space like complexity analysis, so that we can kind of determine the complexity of these answers rather than relying on their non-deterministic metrics. But we're doing pretty good. We just solved this LeetCode problem um, of counting the number of array items that have an even number of digits. And S Vision Sama just gifted us with an extremely clever solution, which is that we solve the problem using base max int. That way, every single number in the array will always be a single digit number, and therefore the answer will always be 0. None of them will have a a an odd number of digits. All about that base, exactly. All right, I'm probably gonna do one more and then wrap it up for the night because I would normally be down to do more, but honestly, the lag on the internet and my computer lagging from running all of this VR stuff is making this a little bit less fun than it would be otherwise. So I'm probably just gonna do one last one and then call it a night. But I will be back next Thursday with my full setup and hopefully a very fancy microphone that I saved from my home office after last week's stream. So yes, look forward to that. And better face tracking and everything as well from my PC. But in the meantime, let's get on with the very last one of the night, the squares of a sorted array. Given an integer array nums, sorting in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. I see. I see. So the trick is that each number can be positive or negative. And um when the array is returned, you got to make sure that the squares are in the correct position with each other. Totoro Slayer says, instead of iterating and dividing n by 10 every time, can you compute the log base 10 of n? That is an interesting question. Log base 10 of n. Number of digits log base 10. Oh, that's interesting. So log base 10 of n plus 1 is the number of digits. That is pretty cool. That is pretty cool. I wonder what the time complexity of log function in JavaScript. Let's just see what. Oh, constant time. Interesting. Well, yeah, you probably could then, and I bet that that would be a more performant answer in a multitude of ways. It's a good math trick to have up your sleeve. Okay, so the very, very stupid way to do this would be nums.map n times n. I don't know if you can do n squared. I'm just gonna do n times n. Dot sort x, y, x minus y. Yeah, squaring each element and sorting. The new array is very trivial. Can you find an O of n solution using a different approach? So let's do the stupid thing first. Okay, we are, there are much better runtime solutions, though. Again, I'm not putting a whole lot of stock in this runtime calculation, but yeah, we can definitely do something better. Optimizing for lines of code. I mean, okay, to be fair, in production, like in industry production code, this would be the right way to do it because this is readable. And normally, in normal everyday web development land, we would really not have a need to optimize it more in most cases. But you know, we could be working in a world with like very large data sets or something like that. In which case, I don't know why we're coding in JavaScript, but here we are. But yeah, we can probably make this better. So instead, O of n implies that we're kind of only touching each number once. So what do we want to do? Well, as we're going through, we could like do something different depending on whether it is a negative or a positive number. We could go from the front and the back at the same time and put, yeah, let's do that. For let I equals 0, I less than nums dot length. I should use Rust. Well, you know, I was saying that on Blue Sky, I'm probably gonna start a poll. I don't know if Blue Sky lets you do polls, but I want to start a poll for what language I should do my next stream in. Because like I was saying, TypeScript is the one that I am the most comfortable with, but I did a fair amount of Elixir back in the day. Would love an excuse to pick up some more Elixir. Rust, I've always wanted to learn Rust and Haskell, and Python also. I never have actually done Python, believe it or not. So there are lots of languages that I would love to learn as I go along. So if you have a favorite programming language, definitely keep an eye on my Blue Sky and give a vote for your favorite language when I put that poll up. Okay, so we're gonna go through all the numbers. Cutting in line in the cafe, exactly. We are gonna cut in line for efficiency's sake. All right. I less than nums.length, I plus plus. Linux Sama, what do you like about Rust? What about Rust makes you happy? It's not going to be nums.length, it's going to be nums.length over 2, I think. Whoops. Because we just got to go to the middle. Okay, so from the front is going to be nums at I, and then const from back is going to be nums of I plus nums of, can we do minus I? Is that? No, that doesn't make sense. Does it? Bring up like a console here. Okay, 0, 1, 2 at minus 1. No, that's not a thing. Okay, that's fine. S-Visions is not being C or C++ what you like about Rust. I appreciate the honesty. Foot guns. So I haven't done any C or C++. What is a foot gun and why is that C and C++? I'm learning all kinds of things this stream. Easy to shoot yourself in the foot. That makes sense. That makes sense. Okay, so we're going from the front and the back, and then we want to check what? If the front and the back are different. Maybe what we need is 2 iterators. We need a front iterator and a back iterator. We got both of those, front iterator and back iterator. And instead of a for, let's do a while front iterator is greater than back iterator. No, less than. Less than. Const front equals nums at front iterator. Const back equals nums at back iterator. And then we want to check why am I struggling with this? We're going from the front and the back, and let's make some examples here. So if we have like -1, -2, -1, 0, 1, 2. I'm missing a semicolon. I am so used to, I should probably just not do semicolons. I'm so used to having prettier to do that for me. So we've got an example where there's more minuses. We've got an example where there's only positives. Oh yeah, in JavaScript and TypeScript, both the semicolons are vestigial. Okay, so if we're going from the front and the back, and it's like completely even, then ideally we would say like, oh, these two, the squares are the same, so they'll go at the back. These ones, the squares are the same again, so they'll go, they'll be basically like shifted in from the front. If it's uneven though, we have like -4 and 1. So it would be 16 and then 1. Oh, thank you so much, Linux-sama! Thank you for coming to the stream. I hope you have good dreams about Rust, and I hope that your dreams do not involve foot guns. Itterashaimase, go shujin sama. I hope that I'll see you next week. Okay, I think what I am starting to realize is that we are going to look at the front and the back, and then the one that is the biggest, so const biggest equals math dot, well, let's just make lots of consts here for clarity. Const front square. Yeah, backseating is totally allowed. I may not do the backseat idea right away, because I may finish out the approach that I'm taking first, but I would love to hear other ideas on how to solve these problems. Okay, so front square and back square. If front square is greater than back square, if the front square is bigger, then we are going to squares, don't know why that's a 0, squares dot shift front square, and then front iterator plus plus. Otherwise, squares dot shift back square back iterator plus plus. Okay, I feel like this is not quite going to work, but I want to see what happens. Console.log squares. Return squares. What happens when I run this? Where is the off by one error? I feel like we aren't gonna... Time limit exceeded! Oh no! While front iterator is less than back iterator. Oh! We gotta do minus minus here. Okay, let's try again. We were incrementing front and back, so they never overlapped. Okay, nums is that squares standard output squares is shift not a thing? Oh, I'm using the wrong brackets. I do that sometimes. All right, let's see how that looks with the correct squares dot shift front square. Oh, shift is not what is it to JavaScript insert at front of array? Is it unshift? Yeah, it's unshift. All right, let's see how far this gets us. No. 1916. Oh, they threw that in there. Okay. I guess if it's one 916. Oh, that's the standard output. 1 9 16 100. It didn't handle the 0. That's interesting. Not a number. Squares. Or it didn't get to the 0 and it started with not a number? I am so confused. Okay, not a number would be the first thing pushed on there. So if front iterator is 0 and nums dot length is the back iterator. We're starting at 1, 2, 3, 1, 2, 3, 4, 5. Oh no, what did you clip? Is my model glitching out? Well, I will never know. Oh. My poor VTuber model. Oh no! You didn't know you were coming to the body horror stream. KK Sham says, what if both iterator is the same index? That is what I figure I am going to be missing. I think there's two problems right now. The first problem is that I'm like skipping the case where they are equal. And then I am also, for some reason, starting with not a number. And I don't know why. The very first thing that gets added is not a number. I'm guessing that back iterator needs to start at length -1. I think that'll get us that'll solve the first problem. Hopefully there's not a number. Okay, and now the numbers, yes, now we just have the problem where if it's, so maybe while less than, front iterator, well, front iterator is less than or equal to back iterator. Will that just fix it? Will that just fix it? Yeah! That seems to have fixed it. Let's try this and see if it all works. Yay! It all works. And it says that the runtime is like the worst it's ever seen, but like I said, I don't believe these runtimes. I don't think that is accurate. I wonder if I run it a few more times if it'll like give different answers each time. No, it still says that. I am curious. I mean, you would think that these would be run on a server. I don't know if it has to do with like how slow my computer is right now, but like this should definitely be more performant runtime than before. Is Unshift expensive? Okay, I guess instead of unshift, we could do .push, and then we can just, like, put everything backwards, right? Will that work? Oh, I am also still console logging, so I don't know if that has anything to do with it, but let's see. Output expected answer. Okay, I guess I gotta actually think through. So we've got our front and our back. Oh, if we're gonna go backwards, we have to start from the middle, I think. So instead, the front iterator is going to start at nums.length over 2. Nums.length over 2, and then let's do math.min. Oh, Oh, can you make squares be the right length at the start and just use straightforward array indexing to put things in the right place? That's probably a simpler go than what I was about to do. Okay, so yeah, let's do that. So instead of squares dot unshift, let's do let current index equal 0. And then squares at current index, squares at current index, and then current index plus plus. I bet that'll work. Let me see if that works, and then I'll remove the console log and we'll see how we're looking. Because that's not valid syntax. I think this is going to be a running theme that as my stream goes on, you're just going to see more and more, like, strange syntax. Okay, what happened? 116.910. Okay, that, oh, right. So it actually has to start, current index has to start at nums.length minus 1, and then current index actually has to go minus minus. Whoa, what is going on in this standard out? The middle isn't fixed. The algorithm would have to find the smallest absolute value element. Current index starts at the end. What is going on? What even is this? -2. Oh! We're getting negative indices? Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay. I messed up somewhere. I think I forgot to put that back. I think that's part of the problem. Okay, I kind of want to put this back to unshift just so that we can get back to the working solution that I kind of strayed from. Squares.unshift. Because I like S-Vision-sama's idea. I just need to do it with working code. Oh, yeah, because that somehow got messed up. Okay. This should work now. This should be the same answer as before. Squares.unshift. Isn't that front iterator plus plus? Isn't that what I had before? What squares? Where's my version control when I need it? Let me just delete that in case that is somehow, it's not, but what? Output? Is unshift not the thing? Unshift. Squares dot unshift. Back square or front square. Why are you outputting nothing? Is it because the while loop is broken? While front iterator is less than or equal to back iterator. Yes, it's because the while loop was broken. Okay, now we're back. We're so back. So squares and I'm just gonna call it I for index. Let I equal 0. Let I equal actually nums dot length -1. And instead of unshift, we are going to insert at squares of I equals front square squares of I equals back square. And then at the end, either way, we're going to do I minus minus. This should, in theory, do the same thing without unshift, I think, unless I am... Okay! Whew! We're so back. Alright, and then if I submit this, I wonder if we will see... Oh, I should probably delete my console log. Some improvement. Let me delete that console log and see if that does anything too. Delete my comments. Why not? Alright, let's see what that does. Okay! We have gotten back to exactly the same runtime as before, though again, I am not going to put too much stock into that because I feel like these answers are very non-deterministic. But this should, in theory, be O of n time, because we are simply going through the entire array once. I think that's what O of n means. So I'm pretty sure we did this in O of n time, even though it doesn't actually look like we made any improvements from the very inefficient, naive approach. When is Frontier GTE? I don't know what that is. What is that? Let's see, Totoro Slayer, did you have a different approach you wanted us to try? I am totally open to new ideas, new ways of solving this problem. Wow, it's so awkward waiting for chat to reply when there's no background music. I promise next week's stream is gonna be way less scuffed. Midori will be having so much fewer aneurysms on stream. And we're gonna have background music, and I'll be on Linux. I'll be programming in like Python or Rust. It's gonna be great. It's gonna be so great. If everything is positive, then we go from front to back, and if everything was negative, then we would go from back to front. So I kind of feel like the solution that you were getting through both sides. That way we can continue to put the biggest number onto the answer as we go along. I'm not sure, like, I'm sure that there are some, like, really crazy ways about this, maybe, but, it's just about as good as we can reasonably get, without doing anything too crazy. I can look at the solutions, though. Solutions. Squares. Oh, this one's locked. 2 pointers from both ends. Yeah, that's what we did. Java 2 pointers, using 2 pointers, 2 pointers, 2 pointers. Yeah, seems like this is what most people seem to be doing. A comparison of lots of approaches. Let's see. What does Heidi have to say? Question. Is a cool one in that there is lots of different approaches, each with its own pros and cons, and then there's also different ways of implementing them depending on whether you are after raw performance or beautiful code. Something slightly irritating is that LeetCode isn't testing with big enough test cases to push the time complexity of the O of n log n approaches below the O of n ones. It goes to show sometimes what wins at the notoriously inaccurate LeetCode time space percentiles isn't always the best in practice or even in an interview. She's noticed it too. There are a few similar approaches we can take here, each with its own subtle differences, all of an O and log n time complexity due to using the inbuilt sort, although they differ in their space complexity. So overwriting input, sorted squares, for I in range of length A of I times equals A of I and then A dot sort. Yes, this approach uses O of 1 memory beyond the input array and is truly in place. However, it is not always a good idea to overwrite inputs. Remember that because we passed it by reference, the original is actually lost. Often functions like this are a part of an API, and in a lot of cases, nobody wants an API that clobbers their input. I think it's best to ask your interviewer if they want something done in place or not. It is a common misconception that we should always be trying to do things in place, overwriting the inputs. Yeah, especially if you ask functional programmers, in which case they would say that we should never be trying to do things in place. Making a new array, not in place, O of n auxiliary space. Clever Python one-liner. Oh no, did the video freeze? Oh no. That might explain. why chat isn't talking to me the last few minutes. I don't know if I have returned, but it might be the internet telling me it's time to log off. Well, I will at least find somebody to raid before I run. Let's see who's streaming right now. Hopefully I pop back in time for my iterashaimase. That would be so sad if I had to go before that. Oh, Totoro Slayer, that's clever. If it's, I don't think that that's gonna work though, because just because something is a negative input or a positive input, you don't know yet, where they will compare to each other once they are squared. Because you could have like positive and negative integers where it's like minus 100, minus 99, minus 98, and then your positive integers are like 1, 2, 3, in which case, like, your positives will go first and your negatives are going to be at the end. Or it could be I do think that you still need to be kind of like comparing in real time, like from the front and the back at the same time, because just by looking at the signs, you won't know where exactly in the list of squares it'll go compared to all of the other numbers, if that makes sense. You'd always still have to be basically like sorting the output as you go in that case. Okay, I am struggling so much even just to simply find somebody to raid. The coding have 103 viewers. That's a lot of viewers. I mean, and your stream looks very cute. But I also kind of want to raid someone with a smaller viewer count, you know? Your video is currently 4 to 5 minutes delayed. Okay, well, I'm gonna find out who I'm gonna pass my stream over to, and then I'm gonna say goodbye, and then I am going to let my stream run for another like 5 minutes so that you can see my goodbye. Oh my lord. All right, let me just find someone to pass this off to. I guess I can do that while I'm waiting. All right, I'm gonna say goodbye. I promise that next week's stream is going to be way less janky. Please bear with me, Go Shujin sama. Thank you for your patience. But we'll be back next week on Thursday once again with some more LeetCode. In the meantime, please stay safe. Study good, drink lots of water, and eat yummy food, and I will see you next week. いってらっしゃいませ、ご主人様. And with that, I am going to transition to my loading screen and let you guys catch up for about 5 minutes, and then I will find someone to raid in the meantime. Thank you so much, everyone. Bye bye.